Assalamualaikum, my name is Muhammad Jokri Binteli, number matric CE 200038. So in this video, we are going to present for our group project. So we are from group 2. First, I'm going to go to the introduction. So for this project, we are required to design a 7-bit ALU, which is arithmetic logic unit. So in this project, we are given two input, which is X and Y. So the value for the X and Y, we can decide by our own. Okay, the ALU process binary data using both arithmetic and logical unit. The operation to perform on this input operands is selected using the control input cell. Okay, next moving on to the problem statement. So for the first one is to use VLSI technology to design the digital circuit, which should be area, performance, and power consumption optimized. Second is to fully understand the Verilog code and ways to do simulation using Synopsys Verilog Compiler Simulator VCS. Third, the circuit should be tested and verified to ensure correct functionality.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Abbas bin Muhammad Ismail, normal matric CE 200132. Today I will explain about objective, which is the first one is to design the module for the arithmetic logic unit ALU with 7 bits. Second is to obtain the output waveform result for the design and perform logic synthesis operation on a Verilog source code using synthesis design compiler based on the specification. To get familiar with VMware Workstation 16 player software.
Okay, so next for the methodology, so we need to derive a truth table that shows the input and output of the 7-bit ALU. Next, we write and run a Verilog code of 7-bit ALU as well as the test bench following the operation given by the question. Next is we need to obtain the simulation and output waveform result for the design. And last but not least, we need to perform logic synthesis operation on a Verilog source code using Synopsys design compiler. So as you can see the picture on the right, we have the flowchart for our process. So this is the continuous from the first flowchart.
Then for the result analysis and discussion, the goal of the project is to use the Synopsys EDA tool to design a 7-bit arithmetic logic unit ALU, create the truth table that display the input and output based on 7-bit arithmetic logic unit ALU design, and the last one is the truth table are constructed with X and Y as input, which is 0, 1, 0, 1, 0, 0, 0, 0, and 0, 0, 1, 0, 1, 0, 0, 0 respectively. And for the last one, for the conclusion, in conclusion, this project achieved all its objectives, including designing a 7-bit arithmetic logic unit ALU module, running the ALU 7-bit Verilog code in Synopsys Verilog compiler simulation, and running simulation obtaining truth table result that matches waveform output result. Becoming familiar with VMware Workstation 16 player and optimizing the specification logic synthesis operation on a Verilog source.
Okay, now let's move on to the demo part for the Synopsys. So the first thing we need to do is open our file location. So I will show for our coding. So the first one we have multiplexer. So this is the coding for multiplexer. And then the next one is for the logic operation. So this is the coding for logic. Okay, next one is for the arithmetic operation. Okay, this is the coding for arithmetic, and then we have for the coding for our test bench. So our test bench is okay. This is the coding for our test bench, and then the other one is coding for our ALU. Okay, so this is the coding for ALU. And then the next thing we need to do is we need to compile and simulate our code. So the first thing that we need to do is to check our test bench. So we open terminal and then write the command. Okay, now we go to simulate the design. Write the command to simulate the design and to display the result graphically. Okay, the VE window will appear after I run the code. Okay, so from here we can check our waveform for the system. So we go to right click, add to wave, and then new wave view. So we click run, and then we need to zoom for the waveform. So this is the waveform for our truth table. So the result is the same as the truth table that we derived. Okay, so the next one is for the logic synthesis using synopsis design. So first thing we need to do, so this is the coding for synopsis DC setup. Okay, now we take out the open terminal, and then we write design vision, so the software for design vision will come out. Then enter. So we need to wait. Okay, after the window has popped out, we need to write the command, which is print var spot, print var target library, print var link library, and then last one, print var symbol library. Okay, now we will select one by one of our operation. We start from multiplexer. Next for our logic. Next arithmetic. And then the last one for our ALU. Okay, now we take out the schematic view to check our block diagram. I can zoom this out, and then double click on the box. So this is the block diagram for our system, for our design 7-bit ALU design.
Alright, after the block diagram have shown, we need to set the parameter, which is first we set the max area to 0, and then we create the clock period, and then set clock transition, set input delay, set output delay, set input transition, and set max capacitance. Alright, and then we compile the design, and we press OK. And then after the design has been completed, alright, after the design has been completed, we go to the hierarchy, and we press the new logical hierarchy, and then we right click on it and schematic view, so we can see the output. And then we double click on the block diagram, and we can see the circuit of it basically. And then we type out the report area on the design vision, and we get the output that we need. After that, we type out the report clock -q, and we get the report that we need. And then we put out the report timing, and then that's it for the design vision. So we create a group, a gedit TCL. We set the max area, create the clock, set clock transition, input delay, output delay, input transition, check max capacitance, and then we go to terminal, and then we do the DC project for the TCL, for our file TCL, which mine is alu 7-bit group 2 .tcl. and then we wait. And then we do the DC project for the run ALU 7B Group 2 TCL. And then before that, we see the how we do it in the TCL, and then we go back to the terminal and we put out the DC project run ALU 7B Group 2 TCL. And then after that, after it complete, we do the DC shell, negative run ALU 7B Group 2 TCL, and dash TEE DC log. So it will show us all of the log that we needed, and then we get the output of it. And then we show the timing report, ALU clock report, ALU cell report, and then lastly our area report. I think that's all for me. Thank you.